Git and GitHub are essential tools for version control and collaboration in the world of programming. In this lesson, we're going to learn how to harness these tools to efficiently manage your projects and to work effectively with others. So let's go ahead and get started. Before I give you the list of things we're going to learn, let me make a few key notes. The first is that Git is very hard. In a university, you may take a semester-long class in Git. Now, we're trying to cover just the essentials, but it will still feel like a lot if this is your first exposure to Git. So what I recommend is take this in slowly. Okay, you can imbibe the content over multiple days. Really take your time. And to actually memorize this stuff will take weeks and months and really years of your developer career. Okay, so Git is hard and prepare for that. However, note that Git is essential. Although Git is hard, it is essential for managing code. So make sure you try to persevere through this process. And finally, note that there's several ways to use Git. You can use the command line, you can use RStudio interface, and so on. What we're going to be using in this course is the GitHub desktop app. So we think this will give you the best bang for your buck in terms of the time investment and how easy it is to work with Git. So with all of that out of the way, let's think about how we're going to go through this lesson. So first, I'll give you a quick introduction to Git and GitHub, and I'll explain what they are. Then we'll set you up with the important software, specifically a GitHub account and the GitHub desktop app. And then we're going to jump directly into what I call an action sequence. Action sequences are just skills or tasks that you commonly have to do with Git. Our first action sequence will be to create a new repo, commit, and publish. Then after that, we'll jump to action sequence 2, where you edit the repo, you commit, and you push. Then once we've gotten your feet wet with that, we'll take a breather and actually go through some key Git vocabulary and theory to help contextualize this stuff. So I don't want to start directly with the Git vocabulary and theory because I think it would help for you to have some actual context of working with it before we get to the vocab and theory. After that, we'll go to action sequence 3, which is to pull changes from remote. Action sequence 4 is to add a new collaborator, resolve a merge conflict, access old versions of files, and the last action sequence will be to fork and clone a repo. Those are a lot of new words. Hopefully you're excited to get into Git. Let's dive in. Now let's start off by thinking about what are the problems that are solved by Git and GitHub. The first problem solved by Git and GitHub is version control. Have you ever struggled with a multiple document or code version problem like this, where you think you're done with a project and you call it maybe just project? You send that version off, you get some feedback, you call it maybe project revised or project 2, and then you think you're finally done, so you call it project final, but then some new changes come along and you call it project final 2, and so on and so forth, and you have this nonsensical set of file names. This is a big problem. Services like Google Docs have solved this by giving you a nice history of your revisions, but for code and for programming, this is best solved by Git. The second problem that Git and GitHub help us solve is collaboration. So imagine you're working on a project and you want to collaborate on it with someone else. What's the best way to do that? One way you may think to do is just keep sending a bunch of email threads. Hey, here's the changes I made. And then they send you back a new version saying, here are the new changes I made, and so on and so forth. As you can imagine, even with 2 people, this can get unnecessarily annoying. But imagine working with 50 people like that. It becomes absolutely impossible. So Git and GitHub will provide us a way to fix this problem. Now I've been talking about Git and GitHub, and indeed these are 2 different things. Let's try to distinguish them. What is Git? Git is an open source version control system that helps you track changes to your code or to your documents over time, as you can see represented in that diagram. And what is GitHub? Well, GitHub is a service, in this case run by Microsoft, so it's not open source, which helps Git users collaborate. So Git is kind of the original system, and GitHub is something built on top of Git that helps users collaborate better. So to get started working with Git and GitHub on your computer, we're going to go through 3 main initial steps. The first is we're going to create an account on GitHub Online, so I'm going to walk you through that. And then you're going to install GitHub Desktop, which is a local software running on your computer. And then we'll connect these 2 services, GitHub Desktop, with your GitHub account in the authentication process. Okay, so let's go through the process of making a new GitHub account. So I'm going to go to github.com and look for the sign up button. So this may change depending on when you come to this page. At the moment, it seems you can just sign up right here on the home page. So I make a password. You should use a good password here, since your GitHub is where you will keep a lot of your important code. And your username is also very important because we're going to use GitHub to share our work with other developers. And even our personal website is going to use this username. Okay, and now I just need to go to my email, I imagine, to verify. All right, so I put in the code and I'm ready. And we're going to, of course, use the free GitHub. Continue for free. Okay, and we are now at our GitHub homepage. And that's actually all we need to do for now. If you want, you can go ahead and click around to explore. But for me, that's all I need for now. So now we're going to try to install GitHub Desktop on a Windows computer. So here I am on my Windows virtual machine, and I just search GitHub Desktop. And it looks like the first result here, download for Windows, is going to be what I need. So I just click on this and I wait for that to download. And so then I go to my downloads folder, and here is the application file. Let's double click on that to install it. So that took about 1 minute to install. And now I'm going to want to connect GitHub Desktop to my online GitHub account. Conveniently, there's a button for that here, sign in to github.com. So I click on that. I use any of the browsers I feel like. Let's use that one. And now the account you just created, you're going to sign in with that. So let me do that. Kendaviden -tgc. And then my password in there. And let's go ahead and sign in. And now I'm going to authorize GitHub Desktop to connect to my online GitHub account. Authorize. And I will click here to always allow GitHub to open links of this type. And click to open that. And now it will open my GitHub Desktop. And now you see it has filled this in on here. So it put in a name and then a special email here. So you can use that and click on finish. And this is now your GitHub Desktop home. And so in the next section, we're going to show you how to use this. There's one important setting you should make after downloading GitHub Desktop. And to do that, you go to File here and then Options. And within the options here, you go to the Integrations. And you should set your external editor here to be RStudio. If you have other coding editors, they may come up here. But since you're going to be mostly working with RStudio projects, we recommend you select RStudio. Now, if you're on a Mac, let's see how you can install GitHub Desktop. So you open your browser or your Google and you just search for GitHub Desktop. And we're going to click the first link. And as you can see, it recognizes that we are on Mac OS, and we can click that main link. If it doesn't do the correct recognition, you can look at these other links. But I'm going to click this one, download for Mac OS. I click allow. Now it looks like when you download the application, it already comes unpackaged. So then all you need to do now is just drag this from your downloads folder into your applications folder. Okay, so find your applications folder, drag it in there. And now you should have that app, and we can double click on it to open it. In my case, it says I need to install Rosetta, so I click install. So that took about 1 minute to install. And now I'm going to want to connect GitHub Desktop to my online GitHub account. Conveniently, there's a button for that here, sign in to github.com. So I click on that. I use any of the browsers I feel like. Let's use that one. And now the account you just created, you're going to sign in with that. So let me do that. Kendaviden -tgc. And then my password in there. And let's go ahead and sign in. And now I'm going to authorize GitHub Desktop to connect to my online GitHub account. Authorize. And I will click here to always allow GitHub to open links of this type. And click to open that. And now it will open my GitHub Desktop. And now you see it has filled this in on here. So it put in a name and then a special email here. So you can use that and click on finish. And this is now your GitHub Desktop home. And so in the next section, we're going to show you how to use this. There's one important setting you should make after downloading GitHub Desktop. And to do that, you go to File here and then Options. And within the options here, you go to the Integrations. And you should set your external editor here to be RStudio. If you have other coding editors, they may come up here. But since you're going to be mostly working with RStudio projects, we recommend you select RStudio. Learning to work with Git is going to involve a bunch of new vocabulary. But rather than spend time initially teaching you all that vocabulary, I want us to dive headfirst into a realistic scenario. So I've conjured up an imaginary scenario that we're going to walk through. And then once we're done with that, we come back and learn a bit more about the theory and the vocabulary behind what we're doing. So here is our fake scenario. Imagine I just got into a new job and I got an email from my colleague saying, "Hello, Kenne. Welcome to the new job. Here's a request from our boss. As part of some market research we're doing, I want to look into the TV hours watched by married versus divorced people. Could you take a look at the General Social Survey and show me the findings?" So General Social Survey is a big survey done in the US that looks at some social outcomes and phenomena. And then she says that I should share my code on GitHub with her so she can check it first. Okay. And conveniently, we can use a dataset that's built into an R package, the tidyverse, called GSSCat. And this stands for actually General Social Survey Categorical Variables. So this is an old GSSCat, and we can use this as part of the silly scenario. And later on, we'll get some recent data. So we're going to go ahead and code this up and try to share it with our boss/coworker. Okay, this is just a simple example to have some code to work with as part of this Git learning process. So here are the basic steps we're going to go through. We're going to create what's called a repository, which is just a fancy word for a folder on GitHub desktop. Then we'll put our R code in it. This is the code that calculates the TV hours watched by marital status. And then we'll publish that to our online GitHub account. So a fairly simple process. Let's see how it goes. So we're going to start by creating this repository. So we're going to open GitHub Desktop in order to create that. So let's go ahead and search for our GitHub Desktop app, which we had installed. And we click here on File and New Repository. And we give this a name. In this case, I'll just call it TV Hours Analysis, but you can call it whatever you like. And if you want, you can give it a specific path, but in this case, I'll leave the default path. This is fine for me. Now, one thing I forgot to mention the first time I recorded this part of the video is that you should definitely add a git ignore file. You don't really know what this is yet, but just add it, okay? So you're going to click here on this drop down and then find the R version, the R template for git ignores, okay? And this is basically going to customize the behavior of Git for the R setting. It will prevent Git from paying attention to certain file types which you really don't need to track. So once that's done, you go ahead and click on Create Repository. And so this has actually just created a repository for me. In order to see this, I can right click here on TV Hours Analysis Current Repository and click on Show in Explorer. If you're on a Mac, it will be Show in Finder or View in Finder or something like that. I click on Show in Explorer. And now it looks like I have an empty folder called TV Hours Analysis inside of my GitHub folder. Okay, but a secret is that this folder is not actually empty. There is a .git folder inside of it, making it a Git folder or a Git repository. In order to see this on Windows, what you can do is you click this ... and I go to the options. If you're on a different Windows version from me, it may look a bit different, so you may need to do some find and seek, or you can Google it. And but for me, it's under ... and then the view folder options here, and I click on show hidden files, folders, and drive here as an option. And now I can see that .git folder. The .git folder is what actually manages the Git versions and all of that. If you are on a MacBook, what you need to do is press the keyboard shortcut, Command Shift and period, Command Shift dot, and it will show all your hidden files. Here we can see that Git folder, a Git ignore, and so on. If you press it again, Command Shift and period, then you hide those again. It is not a folder that you need to look into yourself. It is mostly for the computer to work through the versions, but it's good to know that it exists there. So now we've created a new repository on GitHub desktop. We would now like to put some R code in it. If you already had some R code or an old R project, you could just drag it directly into this folder. But in this case, I don't have any code yet. So I'm going to create an RStudio project out of this directory. So let's do that. I'm going to open RStudio on my computer. And once that's open, I click here on File and New Project. And instead of what I usually do, which is create a new directory, a new folder, I will rather choose this option here, Existing Directory. So associate a project with an existing working directory. The existing directory is my Git folder / Git repository. So many words for the same thing. Directory, repository, folder. They're all kind of synonyms. So let's click on existing directory here. And now we need to find that directory. So I click on browse and I'm going to locate my TV hours analysis. In my case, I think it is inside of documents and GitHub here. And I see it here, TV hours analysis, but it may be a different place for you. And now I can create this new project. So now I've created this new project. If I go back to my file explorer, you will see that this folder, TV Hours Analysis, now has this RStudio project file inside of it. If you don't see it immediately, you may need to click out of the folder and then back in for the folder to refresh. But now I have the RStudio project and I still have the .git stuff as well. So anyways, now we can actually do the simple analysis that we were asked to do. I'll go ahead and create a blank file inside of this folder here. I'll call it main.r. Okay. And I'm going to load the tidyverse package, library tidyverse, or the tidyverse set of packages, because that's where we can get the GSS cat dataset. So let's run that. And now we can look at the GSS cat dataset. As you can see, there's about 21,000 rows and 9 columns. And each row represents someone that was surveyed, and you have the marital status here and the number of TV hours watched. And so our boss wanted to look at the TV hours watched by marital status. So we're going to do a simple table to look at that. I'm going to do Command-Shift-M to type a pipe. And then I'll group by the marital status. And then I'll summarize to calculate the mean. So mean TV hours is equal to the mean of TV hours NA.rm equals true. So we can run this. And now we can compare the married people to the divorced people in terms of the mean TV hours watched. We can see that divorced people seem to watch a bit more TV, 3.1 hours, and the married people are at 2.65 or 2.7. Okay, I don't know whether this is statistically significant, but we're just keeping it simple. So let's go ahead and save this as a CSV so that we can share it with our boss. So I'll call this TV hours table, maybe table. And in order to save it, I like to use the here package to define my paths, even though it's not entirely necessary in this case. So I'm going to say write CSV, and our file is this TV hours table. We'll paste that. And where do we want to write it to? We put it here, and we can give it the same name, but maybe we format it nicely. TV hours by marital .csv. Actually, I don't like spaces in my name, so let's change that to underscores. TV hours by marital. And if we run this, you'll see in here, if we refresh this, that we have the CSV loaded. So make sure that you've actually saved this file. Let me make sure I've saved it. And now let's see where we are on this pipeline. We've created the repository. Now we've put some R code in it. So all we have to do now is just publish that repository to our online GitHub account. So we come back to our GitHub desktop, and there's a lot of scary stuff that looks like it has happened. You can just ignore most of this. Focus on this bottom left part, and we're going to describe in this summary what we have done. We can say, for now, just say started analysis. Okay. Usually this should be a bit more descriptive, but I'll just say started analysis. And I click on this big button that says commit to main. You don't know what commit to main means yet, but just click on it anyways. And then you have another nice big blue button that says publish repository. And that's what we're going to do. We publish it to the web. You can read what it says here. It says, this repository is currently only available on your local machine. By publishing it, you can share with and collaborate with others. Okay, so let's publish it. You can either keep your code private. If you keep your code private, then you're going to have to invite people directly to look at the code. In this case, we don't care whether it's private because it's public data. So we just uncheck that and publish repository. Let's actually go and see if it went up successfully. So you're going to open a browser and then go to github.com where we made an account previously, if you remember. Okay. And this is a bit of a scary page, but on the left side, you can see our top repositories, and we only have one repository at the moment, and that's the TV hours analysis, which we just created. And you'll see that we can click in and view the main.r file, for example, and we see our script there, and we can look at the CSV as well, and it formats it as a table nicely for us there. So what you can do now is you can grab this link, this particular one here, and send that to your colleague, and they'll be able to access that. And if they like the code and they like the findings, then they'll send it over to your boss. So congratulations on the first task for your first job. Now, here is some practice for you. You're going to go through the process again of sharing a data analysis project to GitHub. So here are the steps. Using GitHub Desktop, first create a new repository. You can call it Hello World. And then with RStudio, you're going to turn that Hello World repository into an RStudio project. And then you're going to add a new script to this project. You can call it something like main.r and put some code in this script. In this case, print Hello World. Finally, you want to share this repository publicly to your online GitHub account. Here are some screenshots to remind you of that process. So you go to GitHub Desktop and then File New Repository. Once you've done that, then you go to your RStudio and create a new project, select existing directory, and select that repository that you just created on GitHub Desktop. Then in RStudio, you're going to create a new script here, main.r, and put some code in it, print Hello World in this case. Then go back to GitHub Desktop and put a commit message here. And click this big blue button, commit to main. And soon we're going to explain what that means. And finally, you publish that repository. Okay, so lots of steps, but I believe you can do it. So good luck. So I think we did a good job on that. However, our colleague now asks for some follow-up. She says, thanks for the work sent, Kenne, but the boss asks if you can filter the data to only those above 30. I don't know why they want that, but they want only those above 30. And it says she already has the link, so just let me know when you've updated it on GitHub. So we're going to go ahead and just update that code. Let's open our RStudio project. I think it's already open from the last time. And we just want to filter for those who are age 30 and above. So age greater than or equal to 30. Okay. And Control-Shift-M, and we can just run this again. So Control-Enter or Command-Enter to run all of that. We make sure our script is saved, and now we have updated the code in RStudio. We can go to GitHub Desktop, and if you look at this section, you can actually click on main.r here, and you see that there's this plus, and it shows exactly the change that you've just made. So it tracks the changes that you've made. And even the CSV is tracked. So you can see that the numbers now have changed from when we were looking at the whole data to when we're looking at just those above 30. Okay, so this is the beauty of Git tracking. So now we can summarize what we've done. We said filtered to those above 30, or I think 30 and above, rather, 30 and above. And we can again commit to main. You still don't know really what this means, but you're probably getting a sense that it just means to save. And then again, the big blue button, push origin. This is going to send our work or changes up to the web. So now that we've sent our work up to the web, we can check again on github.com. I don't know why I closed it last time. So go to github.com. We click again on the repository, and this is the same thing our boss will be doing. And you see now that the files that we changed, specifically here main.r CSV, they have a new message beside them, filtered to those 30 and above. And indeed, if we click into the main.r, we can see it's now the version that filtered to those 30 and above. So now we've basically gone through this process of creating a repository, putting some R code in it, publishing that. But then when there were some changes that we needed to make, we came back here, we made some new changes, and we published it or pushed it again. So this is the basic workflow of working with Git/GitHub. In the next section, we're going to dive a bit deeper to understand a bit more about what just happened. Now, here is a practice question for you. You're going to make an update to your Hello World project that we created previously. So with RStudio, open this Hello World repository/project and change the code in the main.r file from print hello world, which it was before, to print hello universe. Okay, and then once you've done that, you go to GitHub desktop, you commit this change, which just means to save the change, and you push it up to your online GitHub account. Then go online and make sure that that actually worked. So pause the video and try that out. So now that you've gotten your hands dirty with a little bit of Git practice, let's now rewind and learn some important Git vocabulary and concepts. So the first word that you've been hearing me use is the word repo, which is short for repository. And the quick definition of this is it's simply your project folder. Okay. Now your project folder contains all your different files and data and a bunch of other things. And this can be either local or remote. Okay. So the local repo is the version of your project folder that's on your local computer. That's pretty intuitive. And the remote repo is the version on some kind of shared online service or network. A very common place to put remote repos is the GitHub website. Okay. And typically we call the remote repo the origin. Okay. So this is indicated here in this diagram. Here's your local repo on your local computer, and the remote repo on an online service like github.com. Now your local repo is typically going to contain a .git directory. That was that hidden folder that we talked about. And that is where all of your changes are actually being tracked. Okay. And it also contains a working copy. That's the current version of the files you're working on. So the Git directory, like I said, is the folder which is sometimes hidden, but you can show it, that keeps track of the file versions. And the different file versions or folder versions are termed commits. And that's actually the next term we're going to think about. So the next term is, what's a commit? Now a commit is both a verb and a noun. So let's think about it first as a verb. To commit your work is to save a snapshot or to save the current version of your work, of your file directory, to this .git directory. So you commit the current version of your working copy into the .git directory. So a synonym, of course, of commit is just to save. So when you save, you're saving that version, and if you wanted, you could go back to that version at some point in the future. Okay. Now, as you're creating these commits, you're piling up a bunch of different snapshots of your folder in this .git directory. At some point, you're going to want to send that up to the online service like GitHub, so that other people can view the code or view the directory, or they can download the code to their own computer. And for that, we use the verb push. Okay, so to push is to upload your latest commits, your latest saves, or basically all of your saves, to the remote repo. So to push is to upload your commits to the remote repo. Now, the very first time you're uploading your local repo to the remote, there's a special term for that, and it's called publish. And so the first time you're creating the remote repo from your local, you're publishing your work to the remote. Okay. Now, when there's some changes in the remote that you need to get to your local computer, to your local repo, the term for that is pull, very conveniently. So to pull is to get the latest commits from the remote repo. Now, the very first time that you are doing this, that you're getting stuff from the remote repo, assuming that the remote repo was created first, then in that case, we use the term clone. So those were a lot of new words we just learned. So here's an opportunity for you to practice. Here are 5 terms, and I'd like for you to match the terms to their definitions. You have push, pull, commit, remote, and repo. And here are 5 definitions. And so I want you to try to mentally figure out what is the correct mapping of the terms to their definitions. So pause the video and try that out. And now that you've tried it out, here are the answers. So to push is to upload your latest commits to the repo. To pull is to get the latest commits from the remote repo. To commit is to create a snapshot of the current state of your working directory. The remote is the version of your project hosted on a shared network like GitHub. And the repo is, of course, your project folder. Now it's time to think about how collaboration fits into the picture of Git and GitHub. So we've established that you have this local repo and you're working on your files, and as you make commits, these get saved in the Git directory, and you can push those commits up to the remote and pull them down from the remote. But then how do you collaborate with other people? Well, it's pretty simple. Let's imagine that Bob is also working on the same repository after he has cloned it to his computer. He similarly has a working copy. He can commit his files, the current snapshot of his files, to his Git directory, and he can do the same thing you're doing. So he can push and he can pull. So typically what will happen is you make some change, you push it to the remote, you'll tell Bob maybe that you've made some change, or he'll just look at the remote and see that it has changed, and he'll pull that down. Maybe he makes some changes, he pushes, and you pull those changes, and so on and so forth. Now here is another opportunity to practice some of that vocabulary. Imagine the following office chat and try to fill in the blanks. So imagine that Adam says to Bob, "Hey Bob, did you start the analysis yet? If you did, can you dash your dash to dash so that I can dash it to my computer?" And here are 4 options for you. So next you have Bob says, "Yes, it's already on dash, but give me until noon to dash my latest dash." Here are the options there. And the last message is Adam saying, "Great, I'll dash the repo now to look. At noon, I'll dash your more recent dash." Here are the 3 options for that. So pause the video and try those out. Okay, I'm assuming you went through that on your own. So here are the answers here. You can take a look and see how well you did. Now let's talk briefly about branches, which is another key aspect of working with Git. So here's our picture so far of how Git works and how it interacts with github.com. And one thing here that is not so accurate is the way we are representing a Git directory. So we are representing it here as a kind of linear sequence of snapshots. But this is not necessarily true because a Git directory is not necessarily linear. It can have multiple different branches. And here's a diagram to illustrate that. So you could have a main branch here. This is one commit, this is another commit. But then at the third commit, maybe someone in the organization wants to try out a different feature. And so they're going to create a different branch and keep working on this branch. And then at some point in the future, after a bunch of commits, they may decide to then incorporate or merge this branch back into the main branch. And as you can see here, feature B never gets merged back into the main branch. And a branch can have a sub-branch, and so on and so forth. Now, in data analysis, we don't use branches that often. This is more used in large software development organizations where you have many different people working on many different features at the same time. So now, after you have digested that set of vocabulary terms, our action sequences should be starting to make a bit more sense. So far we have done 2 action sequences. Our first one, we created a new repository, and then we committed some files to that repository, or to the Git directory of the repository, and we published it for the first time to github.com. Hopefully that now makes sense in the context of this diagram. And then for the next action sequence, we edited the existing repository, right? We edited an existing repo, and we committed again. And then now, since we're just updating things, we're not publishing for the first time, we use the term push. And this is probably the most common action sequence you're going to use when you're working with Git, is you'll make an edit and you'll commit and you'll push it up to the remote repo. If you're collaborating with others, however, then you're going to also need to be pulling. And that's the next action sequence we're going to practice now. So action sequence 3 involves pulling changes from the remote repo that may have been contributed by others into the remote repo. And let's see how to do this. Our next action sequence, we're going to practice pulling changes from remote. So you have pushed changes to remote. Now we're going to pull the changes from remote. And to do this, we're going to simulate being a coworker, since you're only yourself at the moment. We'll simulate being a coworker by making an edit on the online version of the TV hours analysis repo. And then we'll try to pull those down to our local repo. So here I am on my test system, and I'm going to open a browser and go to my GitHub account. So I'm going to go now to github.com, and I am already signed in on my Ken David NTGC account, and I see my repositories here at the left. If you don't see them, you can click on your icon here and then look at your repositories with that button there, and we can see them here as well. So let's go to the TV hours analysis repo. And to make a change on this online repo, I can just click into one of the files, maybe this main.r, and I'm going to change this from those who are greater than or equal to 30 to those who are under 30. Okay, so there's a little edit button here. This may change depending on which at what point you watch this video, but for now it's up here, and I click on that edit button, and I can just directly make the change in the remote repo here, and I click this button to commit my changes, and I put a little commit message. And I can, instead of just update main.r, I can say filter to only those under 30. Now you can also put an extended description, as you could do as well on the local, but for now we just keep only the commit message. And we click on commit changes, and that saves our new set of changes. So now if you go to the home page for the repo, you will see that this file main.r has a new commit message beside it, which is the thing I just did online. But this change that I have made now is only available on the online remote repo on github.com. It's not yet available on my local system. So I'm going to go to my local GitHub desktop now and navigate to TV hours analysis. Okay, TV hours analysis. And if I right click on the section here for current repository, I can either open it in RStudio, or I can show it in my Explorer. For now, I'll just click to open it in RStudio. If you don't see that, you can click first Show in Explorer / View in Finder, and then you double click on the RStudio project. I'm just trying to get the project open in RStudio. So as you can see in the main.r file here, if you don't see it immediately, you may need to open it from the Files tab. As you can see, it's still in the old version, the version I last had on my local repo, which is age greater than or equal to 30. If I want to update this now, I need to go into GitHub Desktop. And here in my GitHub desktop, if I navigate to the TV hours analysis folder, the TV hours analysis repo, over here on this right-hand side button, you see there's an option to pull origin, to pull from the origin. So if I click on this, it's going to pull the latest changes. And now that is all done. It has pulled the latest changes. So if I go back now to RStudio, you'll see that this just changed from greater than or equal to less than 30. So I'm now able to continue working based on the changes that were made on the online remote repo. And if I go to my GitHub desktop here, and I look at the history tab of this repository, so TV hours analysis history, you can see that change that was made by me online, filter to only those under 30. So going back to our slides, what we just did is we simulated being a coworker. We made an edit on the online version of the repo, and then we pulled those changes, those latest commits, to our local repository. Now here is a practice question for you. I want you to practice pulling changes from the remote. So what you're going to do is reproduce a similar process on your Hello World project. Okay, so you're going to go to github.com, and you're going to be pretending to be Bob, and change the code from Hello Universe, or whatever it is at the moment in your main.r file, to something else, such as print goodnight moon. Okay, and then try to pull those changes from the online, from the remote, from the origin to your local repo. Now in the previous action sequence, when we practiced pulling changes from the remote, We were pretending to be a collaborator. We were pretending to be Bob by making the changes on github.com. However, if you wanted to actually invite this theoretical Bob to contribute to your project, you need to add a new collaborator. And that's our next action sequence. And this is a fairly simple action sequence, okay? So here is our diagram showing basically how Git and GitHub work. And we had said that in theory, Bob can push to your repo and pull from your repo. But if literally anyone could push to your repo, then your repo would be a big mess, right? So you need to give Bob some kind of access, and that's what it means to add a new collaborator. So let's see how we can do this. We're going to open up github.com to learn how to add a new collaborator. So I'm going to go back to my browser and open this TV hours analysis repo. And on the left-hand side of the repo menu bar over here, you'll have a settings button. So here it's hidden because I'm really zoomed in. If I zoom out a bit, you'll see it should show up. Okay, so you have the settings button. And if you click on that, here you have a bunch of settings about this TV hours analysis repository. The most important one that we're looking for at the moment is collaborators. So it's actually the first one here on this left-hand side. So if you click on collaborators here, it asks me to confirm my password, which is okay. And now I can add access to other collaborators. So I'm going to add one of my other GitHub accounts. I'll click on Add People. And here you can search for them by their username, their full name, or their email. I'll add my other GitHub account, which is just Ken David N. And I will add this person to the repository. And so then this Ken David N would need to log in on his computer and accept that invite. And then this Ken David N would be able to modify my repository. So they'd be able to make commits, make changes, clone the repo to their own computer, and push any changes. And that way we can work together and share our commits. Now, the next action sequence we're going to look at is resolving a merge conflict. Now, what is a merge conflict? The merge conflict comes up when the changes that have been made by another collaborator and that have been pushed to your remote repo are incompatible with changes that you are now trying to push. Now, when that happens, you're going to get a merge conflict if you try to push your recent commits. And we're going to see how to resolve such merge conflicts. To do this, we're again going to simulate being a coworker, and we'll make some online changes on GitHub Online, the github.com website. But then we'll also make a local change that conflicts with the online change. So we'll change the same part of the file, both on our local computer and on the remote on github.com. And then we'll practice how to deal with the merge conflict that arises. So we're going to start by making a change on the remote repo. So open up your TV hours analysis repo on github.com. And we're going to go into our main file, the main.r here. And we're going to make a simple edit. So I'm going to click on edit this file. And the edit I'm going to make is simply going to be to change this TV hours table to maybe TV hours tab. Okay, and I'll do that both here and here. So imagine that your online collaborator, for some reason, thinks it is better to call this TV hours tab and their TV hours tab as well instead of table. I don't know why they would do such a thing, but just imagine they did so. And then now I'm going to commit these changes. And maybe your online person says, I just wanted to shorten names. Okay. And we commit these changes to the main branch. So now that I've made those changes online, I'm going to go to my local repo. So here I am on GitHub, and if you don't yet have it open on RStudio, you can right click here again and click open in RStudio, but hopefully you still have that open. Now here in the main.r file, let's imagine that my local person wanted to actually make this name longer. So I'm going to call this TV hours tabulation. And then here I'll put also TV hours tabulation. Okay, so your online collaborator wants it short, and you want it as long as possible. So you've made changes in the same parts of the script. And so now I'm going to open up my GitHub desktop. And what I want to do is what I always do, which is I'm going to commit my new changes. And here I'll say, make names longer. And we don't need a more detailed description. We click commit to main. And once you've committed, the next thing you would usually try to do now is to click this button to push to origin. So let's try clicking that. And oh no, we have a small complaint. It says there are some newer commits on the remote. So we need to actually get these first before we can push. So let's follow what GitHub says and click here on fetch. And fetch is another GitHub command. I know there's a million GitHub commands, but in this case, you don't really need to think about what it means. It basically is just checking to see if there are any commits on the online repo. Okay, so we're going to do the next thing which it asks us to do here, which is to pull the commit from the origin remote. And this is where we're going to see the real merge conflict. So we made our change, we committed it, and we tried to push, but it didn't really work because there are some more recent commits on the remote repo. So now GitHub is aware of those. So let's see if this pull is going to work. So as you can see, when I clicked on that pull, it took a few seconds, but as you can see now, it says there's one conflicted file, and there are two conflicts in that file. And the big blue button here is grayed out, so I can't actually continue. So what do I need to do? I need to resolve that merge conflict. Let's go ahead and open it in RStudio to see what it looks like. Okay, so here I am in RStudio, and we have this very scary thing that has happened to our script. So this used to be our main.r file, but now it looks super scary. But I promise you it's not that scary. Let's start with this first part up top. Remember that our fake online collaborator wanted the names to be super short, TV hours tab, and we wanted the name to be super long, TV hours tabulation. So what Git has done is it has separated our two changes into these two lines. This is the one that comes from me. This is the one coming from my local repo. And this is the one coming from the remote from the coworker that we were simulating. And they're separated by these sets of equal to signs. And this whole conflict is wrapped by these less than signs here and the greater than sign. So that's really all you need to know. There's also the word head here and the long hash, but those are not super important. So really all we have to do is we need to decide which of these do we want to go with. Do we want to go with the one that's coming from us, TV hours tabulation, or the one that came from the online repo? And the one coming from us is going to be at the top, and the one coming from the online repo is going to be at the bottom. In this case, I want to use the one that I put, and that's this top one. So all I need to do is I'm going to delete this version that came from the online repo, and then I delete all of these artifacts of the conflict. So this stuff here, and this stuff, okay, and that stuff. All right. So now I have resolved the first merge conflict. Now, if by chance I forgot that there was this other merge conflict here, maybe it was further down in the script and I didn't see it, and I tried to go to GitHub to continue with this merge, you'll see that GitHub still says there's a conflict. So we resolved one of the conflicts. Remember, before there were two, now there's just one. So we still haven't finished. So we need to resolve also that other conflict. And the way that git/GitHub knows of the conflict is it can see these little syntax things. So it sees these syntax elements, and therefore it knows there's a conflict. And since we went up top with the TV hours tabulation, of course here we should also go with this TV hours tabulation. So we can delete this line, delete this line, and then delete these annoying syntax things, okay? And really you can edit all of this the way you normally edit a file. It's all just regular text that you can edit. And let's bring this back up to the top. So now that we've removed all those markers of merge conflicts from our script, we can now go back to GitHub Desktop. And very nicely for us, it says all the conflicted files have been resolved. So we can continue with the merge. And now finally, we can push to origin. Now, when you push to origin, it's going to ask, are you sure you want to force push? This sounds a bit scary, but I promise it's not that scary. So you just click on I'm sure, and we're going to push that to origin. Okay, so that was a lot to take in. Let's see if we can revise what just happened. So we simulated being another collaborator. We simulated that we were maybe Bob, and we made some changes on the remote repo. In reality, this would be someone else making changes and pushing to the remote repo. But in order to simulate that, we made those changes directly on the remote repo using github.com, okay? And then we tried to make some changes in the same lines on our local repo, okay? However, when we tried to push these over to the remote, it didn't work because there was a conflict, okay? And we needed to resolve some weird syntax issues in order to then finally push. Now, in order to get all that complexity into your brain, you're of course going to have to practice it. So here's some practice questions for you. You're going to try to resolve a merge conflict on your Hello World project. So we're going to reproduce a similar process to what we just did on Hello World. So first you go to github.com and you change the main line of code that we have in that repo to print Hello World, all capitals. So you're simulating being an online person, maybe Bob, that wants it all in capitals, okay? And then without pulling, you're going to make a conflicting change on your local version. So once you've done that change on GitHub Online, you come to your local version, open up RStudio, and you change it to all lowercase. So print hello world, all lowercase. And then now you're going to try to commit and push this. So try to commit these local changes. That should be successful. And then try to push them. When you try to push them, you'll get all of the issues that we saw before, okay? And I want you to go through the process to actually resolve this and successfully commit. Now, as you have seen, the process of resolving merge conflicts is quite painful. And so you may be wondering, how can I avoid this? Well, there's only one tip I have for you to avoid this, and that is to commit your work and push it up to the remote repo very often. Because in our example, the only reason I had to deal with all of those conflicts was because Bob, our theoretical online person, made their changes and pushed them to the remote first. If I made my changes first and I sent them to the remote, then it's Bob who's going to have an issue when he tries to push his changes. So try to commit and push often, and you will move the burden of handling a merge conflict to your other coworkers. Now, of course, I'm partly joking because it's generally good to commit and push your work often because it prevents your work and your coworkers' work from deviating too far. If you all are committing and pushing often, then you will run into fewer merge conflicts, and when you do run into merge conflicts, it'll be really small merge conflicts that you can fix quickly and easily, rather than very huge conflicts which can take a lot of time to resolve. Now, our next action sequence concerns accessing old versions of your files. Since Git is a version control system, it should allow us to access old versions. And this is indeed the case. So this is our diagrammatic illustration of how Git works. And what we're trying to do is, for example, access an older commit. Now you can access the older commits either from your local repo or from the remote. I'm going to mostly show you how to do it from the remote, from github.com, because it's a little bit easier. So like I said, what we're going to do is we'll go to github.com, we're going to view the old commits, and then you could just copy the old state of code or download the whole repository at that point. And there are ways to do this locally, but these involve more steps. So we're going to focus on the github.com version for now. And if you want to, you can look into this on your own time. So it's pretty simple. You're going to go to your repo homepage on your github.com account. And over here, we see that there's a button for the number of commits. So I'm just going to click on that, and that'll take me to the list of all the commits. These are all of the saves. If I want to access a specific one, the state of the files at that specific one, at the right-hand side, you have this option here to browse the repository at that point. So if I browse at that point, for example, now, and I click into any of these files here, this will show me the state of that file on that old commit. And you can therefore just copy the code and go paste it back into your script. Now, if you have multiple files that you want to recover, it may be easier to download the whole repository at that point. So let's go back again to our home page. We click on this, and you can tell that we're on the main because the URL is just TV hours analysis. But if we go to one of the older commits, let me just quickly show you that. If we go to one of the older commits, let's say this one, you'll see that the URL now changes. So it has this long commit hash showing you're not on the main. So here I am now on an older commit, and if I want to download the state of the code at that point, I click on this big code button, and I can download the zip file that will contain all of those files. So then I can copy that and paste it into my repo. And that way I recover the state of the files at this specific point. Now, although it's a fairly simple skill, I want you to still practice accessing old versions of your files. So with your Hello World project, go to github.com and just spend some time browsing the old commits of your files. Make sure you know where all those buttons are. Now our final action sequence is going to be to fork and clone a repository, an existing repository. Now this is the first time you've seen the verb fork in the context of Git. What it basically means is you're going to make a copy of somebody else's online repository into your own github.com account. All right, so you're basically copying it from someone else's account into your account. And then once you've done that into your account, you can then clone it to your local computer. You can clone this remote repo into your local computer and you can continue editing it. Why would you need to do this? Well, there are many interesting repositories online that you may want to recreate. Very commonly for academic studies, people post their GitHub repositories that allows others to recreate all of their analyses. So you'll find online repositories and you can fork them, clone them, and actually do the analysis on your computer. And if you're taking one of the Graph Courses boot camps, probably we will be asking you to fork and clone some repositories. So let's see how we can do this on github.com. What repository are we going to fork? Well, we have created a small repository that we want you to practice forking. And to get to it, you're going to go to your browser and then to github.com/the-graph-courses. That is the Graph Courses GitHub organization. So you can actually have organizations and add many people to the organizations, but you don't need to think about that for now. In any case, we have a list of repositories, as you can see here. About 27 of them are public. And if you search through our repositories here, it's the first one, but you may need to search because when you come, it probably won't be the first one anymore. And it's called Fork Practice. So just click on it. And at the top right of Git here, you can see this fork button. Fork your own copy of the Graph Courses Fork Practice. So I'm going to click on this. And now we are creating a new fork. And as you can see, we can keep the same name because it's no longer on the Graph Courses account. It's now on Ken David and TGC. Okay. And I'm going to go ahead and create that fork. Now that I've created the fork, this is now one of my personal repositories. And I can clone it down to my local computer and edit it. In order to do that, I'm going to click here on this green button that says Code. And I'm going to say Open with GitHub Desktop. And this is going to clone it to my local computer. Let me click Allow. And it asks me to confirm the name of the repository, that's correct, and where I want to put it on my local computer, the local path. This is fine. I keep it in GitHub/fork practice. Okay. And I'm going to click here to clone that repository. So now this fork practice is a folder on my local computer. I can right click on it to show in Explorer and I can see it. So it's just a simple RStudio project and it has this main.r file in it. Because it's an RStudio project, I can open it directly in RStudio. So I right click here and I click Open in RStudio. And I can open the main file and see the nice message in there for me. It says, hello, just checking that you know how to fork and clone a repository. This is a simple R script that prints a message, print, welcome to the repository. So this was a successful fork. So congratulations, you have gotten to the end of this lesson. Let's go over the key action sequences again, just to rejig your memory. The first thing we learned was how to create a new repo using the GitHub desktop app. We saw how to commit a change and how to publish that to your remote repo on github.com. We saw how you can make changes to that repo and then push those changes, those most recent commits, to the remote repo on github.com. Then we saw how you could pull changes from the remote repo. We simulated being another collaborator that was sending those changes in, and then we pulled those into our local repo. Then we looked at how to add a collaborator to your repo so that they can indeed push changes into that remote repo. Then we looked at what happens when you and a collaborator make changes on the same line of a file. And what happens, of course, is you get a merge conflict, and we looked at how to resolve those. Then we looked at how to access old versions of your files, and I said that the best way to do this is just to go online to github.com, and we saw how to do that. And finally, we saw how to fork a repository from someone else's repo into your own github.com repo, and how to finally clone that to your local desktop so that you can continue to edit it. So as I mentioned, Git is hard. Hopefully you now appreciate that. I don't know how long you took to watch this, but it would have been good if you took multiple days. Like I mentioned before, it's going to take weeks to digest, though. But like I said at the start of the lesson, Git is essential. So thank you for persevering this far. And there are several ways to use Git like I mentioned initially. You can use the command line or RStudio interface. We have now taught you how to use GitHub Desktop. When you get advanced, you may want to start learning some command line terms, but GitHub Desktop will get you very, very far. And here are the things we covered. We introduced ourselves to Git and GitHub. We set up a github.com account and a GitHub Desktop app. We learned how to create a repo, commit and publish, how to edit, commit and push. We learned some Git vocabulary and theory. We learned how to pull from remote, how to add a new collaborator, how to resolve a merge conflict, how to access old versions of your files, and how to fork and clone a repo. So congratulations, you can now say that you know how to work with Git. With this newfound skill, you are equipped to work efficiently with others and to manage your code effectively. I'm proud of you, and I will see you in the next video. Bye-bye.